This is a quick little tutorial on limiting reactants. Limiting reactants aren't actually really anything new for you. There's really no new calculations or anything like that. It's more of just dealing with a concept here. So this idea behind limiting reactants, or sometimes you might hear the term limiting reagent. And that's the same idea. A reagent is like a chemical that you use. Sometimes you don't have the exact amount you need to complete a reaction when you're mixing together chemical A or chemical B. Oftentimes, one or more of the reactants will be in what's called excess, which means you have too much of it. Okay, so you've got this idea of peanut butter and jelly sandwiches. If I go to Costco, okay, and I get the big jar of peanut butter, and I get the ginormous jar of jelly, okay, but I have 4 slices of bread. How many sandwiches can I make? Okay, so that's the question there, and automatically you know you can only make 2 sandwiches. Okay, so what we would say is the bread is the limiting reactant. And LR is how we abbreviate limiting reactant or limiting reagent. Okay, and then we would say that the peanut butter and the jelly are in excess. And again, that's the abbreviation for excess, is the letters XS. Okay, so that's the idea of limiting reactants. So when you're solving these for a chemistry class, what you're going to find is you are going to have 2 starting amounts in the problem. Okay, so 2 starting amounts. And what you're going to do is you're going to work the problem to the end with one of the reactants, work the problem to the end with the second reactant. The reactant that gives you the smallest answer is the correct one every single time. Okay, so every time, no exceptions on that. We'll talk a little bit more about that after I finish showing you a calculation. This tells you that the other reactant that you started the problem with must be in excess. Okay, so let's look at our problem here. We have 90 grams of sodium added to 100 grams of water to form sodium hydroxide and hydrogen gas. Our first question is, how many grams of hydrogen gas are produced? And then, what is the limiting reactant? What's in excess? Okay, so you can see here in the problem, we have 90 grams of sodium and we have 100 grams of water. So here's our 2 reactants, 90.0 and 100.0 grams of water. And we're asked here in question number 1, how many grams of hydrogen am I getting out of the problem? Okay, so this would be just like if you were going back into the lab and you would just take all that sodium and all that water and mix it together. How much hydrogen would you get? Well, with 90 grams of sodium, you'd actually get a big boom. Okay, so here's our problem, just with a little bit more space. We've got the 90.0 grams, we've got the 100.0 grams, and we're asked about grams of hydrogen. So to answer our question here, okay, I said you work the problem once with the one reactant and then a second time with the other. So I'm going to do 2 stoichiometry problems. I'm going to do the first one with 90 grams of sodium, and I'm going to take it all the way to the grams of hydrogen. Okay, so 90 grams of sodium, diagonal down, same units, moles of sodium, diagonal down, same units, moles of sodium. This is my mole ratio, so I go to moles of what I'm looking for, which in this case is hydrogen, diagonal down, same units, moles of hydrogen, and finally 2 grams of hydrogen, what I'm looking for. Okay. Moles on top of grams, moles gets a 1, grams comes from the periodic table, 22.99. Here's my mole ratio that comes from my balanced equation, 2 moles of sodium, 1 mole of hydrogen, and then here, moles in grams again, 2.02. I worked that through my calculator and round it to 3 sig figs, and I get 0.395 grams. Okay? So that's one problem. I'm going to change my pen color here. Whoops. And so we can work the second problem. So really the only difference with these is you're doing two problems. So now I'm going to do a second problem. But this time I'm going to start with the 100 grams of water. Okay? And I am going to solve for hydrogen gas, just like the last one. Okay, so grams of water, moles of water. Diagonal down, my mole ratio here, moles of H2O. Now it's to moles of hydrogen, and then grams of hydrogen. Okay, moles and grams, moles gets 1. Water, if you don't know it by heart already, 18.02 off the periodic table. Here's my mole ratio. Looking at my balanced equation, hydrogen's a 1, water is a 2. Okay, and this end part is always going to be the same. Okay, notice this is exactly the same. So you only have to do this molar mass once, 2.02 and 1. And again, I do the math on the calculator. This one actually has, well, no, it's got 3 sig figs because of the 2.02. So this would be 5.60 grams of hydrogen. Okay, and this was grams of hydrogen. So the question is, which one is the real answer? Okay, and the answer to that is it's always the lowest. Always. Okay, so for this one, it's this right here. Okay, 3.95 grams of hydrogen. That really does not look like H2. Grams of H2. So it doesn't matter what I do the calculations, one with the other number. The lowest answer always wins without exception. If we look back at my peanut butter and jelly example, okay, they sometimes will try and trick you with the wording. They might say, what's the maximum number, given these conditions, the big Costco jars of peanut butter and jelly and 4 slices of bread, what's the maximum number of sandwiches that can be produced? Well, the answer still is 2 sandwiches. Okay, just because I use the word maximum doesn't mean I go for the biggest number. I still can only make 2 sandwiches. So here, if they try and ask you what's the maximum amount of hydrogen that can be produced under these conditions, it's 3.95 grams. So then question 2 is, what's the limiting reactant? What's the excess? Well, 90 grams of sodium made, we said 3.95 grams of hydrogen. And we had 100 grams of water, and 100 grams of water made 5.60 grams of hydrogen. Okay, so for my limiting reactant, okay, what is my limiting reactant? Well, my limiting reactant's the one that got me the lowest. So 90 grams of sodium, this is my limiting reactant. Okay, and what reactant is in excess? Okay, what is in excess right here in yellow? This one would be in excess because it's what gave me the most. Okay, so just to recap real quick, limiting reactant problems aren't anything new. It's still the same stoichiometry you know and love. Okay, it's just the difference is you have 2 starting amounts and you do 2 problems. That's the only difference. And remember, the smallest answer wins every single time, no exception.